A computer observes some data, builds a model. Based on the data model as both a hypothesis about the world and a piece of software that can solve problems. That's called machine learning, according to the book Artificial Intelligence, A Modern Approach. Now let's listen intro.
Welcome to the OTech Talks podcast, where it's all about working on technologies. You will hear the latest tech information, and your host, Kashif Manzoor, brings together product overviews, how-tos, best practices, tips and tricks, and troubleshooting techniques.
Welcome to OTech Talks podcast. It's a journal. If you're new to the show, today our session number is 80. And we will discuss about the basics of machine learning. Open Tech Talks is your weekly sandbox. If you're new or if you're an old listener, thank you so much for always sharing your feedback and to be a good listener, to understand, to listen, to spend time with me. And we both are learning and improving together. So Open Tech Talk is your weekly sandbox for technology insights, experimentation and inspiration, with the primary objective of learning and sharing. As this is our sessions number 80, and we have started now 3 key areas. One was AI, machine learning and data science. And in session number 77, we had a discussion on the brief history of artificial intelligence, past and present. And then we went into Sudoku puzzle, how to solve it, and some practical. And now we are back with the machine learning topic, where we thought, let's go from the basics. And that's the way I learn usually, that I start from a very like a zero knowledge, and then I build up on that foundation. And so machine learning is a branch of artificial intelligence focused on and applications that learn from experience and improve their decision making or predictive accuracy over time. Why we would want machine to learn? Why not just program it the right way to begin with? And according to the book, which is very famous, the 4th edition, Artificial Intelligence, A Modern Approach, there are 2 main reasons to that one. First, the designers cannot anticipate all possible future situations. If I'm designing it or you're designing it. For example, a robot designed to navigate mazes must learn the layout of each new maze it encounters. So when the maze keeps changes, it need to learn it. A program for predicting stock market prices must learn to adapt when conditions change from boom to bust. So it means every time we need to change, we need to adopt. And the second area is, or the point is, sometimes the designers have no idea how the program or a solution will work, or how it will be programmed. Most people are good at recognizing the faces of family members, but they do it subconsciously. So even the best programmers don't know how to program a computer to accomplish certain tasks, except by using machine learning algorithms. Now, the technology of machine learning has become a standard part of software engineering. That's what we are nowadays seeing it. Anytime you're building a software system, even if you don't think of it as an AI agent or AI as an algorithm, components of the system can potentially be improved with machine learning. And that could be some example: software to analyze images of galaxies under gravitational lensing was speeded up by a factor of 10 million with the machine learning model. And then energy usage of cooling data centers was reduced by 40% with another machine learning model. And then there is another famous one where the Turing Award winner David Peterson and Google AI head Jeff Dunn declared the dawn of a golden age for computer architecture due to machine learning. Now, when we say golden age of the architecture, it's all due to the machine learning and the artificial intelligence. Now, what is the formal definition? What is the definition of formally for machine learning? Machine learning algorithms uses statistics to find patterns in massive amount of data. And when we talk about data, it covers a lot of things: numbers, words, images, clicks, whatever you have it. and it can be, as long as it can be digitally stored, it can be fed into a machine learning algorithm. And machine learning is a process that powers many of the services we use today. Now, from another definition from the book Foundations of Machine Learning, second edition, machine learning can be broadly defined as computational method using experience to improve performance or to make accurate predictions. Now, here the experience refers to the past information available to the learner, which typically takes the form of electronic data collected and made available for analysis. This data could be in the form of digitized human labeled training sets or other information obtained via interaction with the environment. In all the cases, its quality and size are crucial or critical to the success of predictions made by the learner, because the learner is taking from the experience of the previous data. The machine learning consists of designing efficient and accurate prediction model algorithms. And in other areas of computer science, some critical measures of the quality of these algorithms are their time and space complexity. But in machine learning, we all need additionally a notion of sample complexity to evaluate the sample size required for the algorithm to learn a family of concepts. Or we can say theoretically, learning guarantees for an algorithm depend on the complexity of the concept classes considered and the size of the training example. Now, we talk about another area on the so what we understood from it, that machine learning algorithms uses statistics to find patterns in massive amounts of data. And data here, it considers a lot of things. Numbers, words, images, whatever you name it, it's as long as it's digitally available. And now if we take it, machine learning as the process that powers many of the services we use today. For example, the recommendation system of Netflix, which we use, or a YouTube, or a Spotify, all these are search engines like Google, Baidu, social medias, all which we use, Facebook, Twitter, even Siri, Alexa, all are based on what is behind the scene is the machine learning, the massive amount of data from where they are learning it, they're taking it, what is that uses patterns, what users are watching, viewing it, and based on that one, deciding it, what could be the best next action on it. And there are a number of methods to machine learning, but before we will go to machine learning, let's understand a sample. When we want to get the computers or the algorithms to get trained or the machines to learn it. Take an example, there's a common understanding, and that's described by by David S. Rosenberg in Black Box Machine Learning in Bloomberg Machine Learning Education course. And he argued that okay, there's a common theme to solve a prediction problem given an input X and predict an appropriate output Y. Now takes an example of if you're getting an incoming email from anyone. Now output is spam or not spam, right? So it's a binary classification problem where we have only two possible outputs. Or if we go in a diagnosis from a medical point of view, input is maybe if a person is going, it can be fever, cough, or fast breathing, shaking, nausea. Output can be diagnosis, can be pneumonia, flu, common cold, bronchitis, or anything. So now it can be in this one, it's a multi-class classification where it's a problem choosing one, and the output could be several outputs. For that one, what was happening similarly on the predicting a stock price, if history of stock price, and the output of the stock price. Now, what was happening? A prediction function takes input X and produces an output Y. So what happens that it gives you prediction functions that solve particular problem. Now, definitely this one is the trained model where you give the data and then it gives you the best prediction function. So what we can say is the machine learning is not a rule-based. When we say rule-based approach, it's a very common from 1980s that okay, if you want to diagnose, you You talk to an example of a rule based that okay, which were usually common as expert systems. These are rule based systems. Now, how the rule based system was up working, you study the problem, write rules, and then evaluate, and then launch or exhibit what you learned it from it. And if it didn't work, then you go back to analyze the errors, and then you comes back to write the rules. That was the rule based approach, and it was very famous in 1980s, where you write based on an intelligent rules which will evaluate or give you the output. Now there's a problem with the rule based systems. What is this problem? Is it very labor intensive to build? And then what has happened, rule work very based on the data, then it will, if it get changed or get modified, then what happened, then you need to go back to the data and change your rule. Now when we talk about machine learning and modern artificial intelligence, it don't reverse engineer an expert decision process. Machine learns on its own. We provide the training data. For example, input X, output Y, we pairs it. A set of videos and whether or not each has a cat. A set of emails and whether or not each has a spam email. Now learning, and then there are supervised, there are definitions, there are types of learning. We will go in our next stages. But from a machine learning algorithm point of view, how it works is you study the problem. Next step is you train the machine learning algorithm based on the data. So you study the problem, you train the machine learning algorithm based on the data, you evaluate the solution, and then you launch it. If it didn't work, then you go back to analyze errors. But you train the machine learning algorithm based on the data. And I will put it in the show notes, this flow chart in the otechtalks.tv in the blog. So to summarize the discussion on the machine learning, and then we will go to the type of that at very high level or a broader spectrum. Machine learning is the process of teaching a computer system how to make accurate predictions when we feed the data. And these predictions could be answering whether a piece of fruit in a photo is banana or an apple, or spotting people crossing the road in the front of self-driving car, or whether the use of the word book in a sentence relates to a paper book or a hotel reservation. So you name it anything. That's how it defines in simple words the machine learning. Now we used another word which is in algorithm. So in data science, the algorithm is a sequence of statistical processing steps. And in machine learning, algorithms are trained to find patterns and features in massive amounts of data in order to make decisions and predictions based on new data. The better the algorithm, the more accurate the decisions and predictions will become, as it all processes the more data. Now, the next our topic of this talk is the machine learning methods, because there's another key area when we talk about the machine learning methods. There are common machine learning methods, which is supervised learning, unsupervised learning, reinforcement learning, or semi-supervised learning. But I would love to take some information from the machine learning mastery, Jason, where he put it 14 different types of machine learning or learning in the machine learning, and where he categorized into learning problems, where supervised learning, unsupervised learning, reinforcement learning, then the hybrid learning problems, he named it to semi-supervised learning, self-supervised learning, multi-instance learning, statistical inference, inductive learning, deductive inference, transductive learning. Then there are learning techniques, multitask learning, active learning, online learning, transfer learning, ensemble learning. All these are types of the learning in the machine learning. Today we'll focus primarily on the four areas, which are supervised learning, unsupervised, reinforcement learning, and semi-supervised learning. Now, when we talk about supervised learning is the learner receives a set of labeled examples as training data, and makes predictions for all unseen data points. This is the most common scenario associated with the classification or regression or in ranking problems. The spam detection problem discussed, for example, we spoke on that, okay, how to, if you are getting an email, is it spam or not spam? So in other words, the supervised learning where it observes the input and output pairs and learns a function that maps from input to output. An input could be a camera images, each one accompanied by an output saying bus or pedestrian. An output like this is called a label. The agent learns, or the computer program learns a function that when a given new image predicts that the appropriate label is the pedestrian or a bus. So that's how it's called as a supervised learning. Now, the supervised learning, another definition from the pattern recognition and machine learning book, that applications in which the training data comprises examples of the input vectors along with their corresponding target vectors are known as supervised learning. So basically, it has a learning is a search through the space of possible hypotheses for one that will perform well even on the new examples beyond the training set. To measure the accuracy of hypothesis, we give it a test set of examples that are distinct from the training set. That's how it is called the supervised learning. And in a common language, the supervised learning is where you train during the training of the supervised learning, systems are exposed to large amounts of label data, and we spoke already in images, handwriting and all that one, and then from that one input and output are paired together from where you learn it, and then they predict it that this is how the supervised learning is. Now in unsupervised learning, it learns the program, the patterns in the input without any explicit feedback. That's the most common unsupervised learning task is clustering, detecting potentially useful clusters of input examples. For example, when shown millions of images taken from the internet, a computer vision system can identify a large cluster of similar images, which an English speaker could or would call cats. So unsupervised learning, the learner exclusively receives unlabeled training data and makes predictions for all unseen points. In the supervised learning, you remember we paired it input and output, and then we trained that, we gave that data. In that we will not label it. So we will no labeled examples will be available. So it will correlate different objects and then it predict from that one. So it make a cluster. That's how the unsupervised learning is labeled as or talked about it. So unsupervised learning describes a class of problems that involves using a model to describe or extract relationships in data. Compared to supervised learning, unsupervised learning operates upon only the input data without output or target variables. So in unsupervised learning, there is no instructor or teacher, and the algorithm must learn to make sense of data without this guide. That's according to the deep learning book definition on that one. Now we will move into the next one, which is our next third type of the machine learning, which is reinforcement learning. Now in the reinforcement learning, the agent learns from a series of reinforcements, rewards and punishments. For example, at the end of a chess game, the agent is told that it has won a reward or a lost, a punishment. It is up to the agent to decide which of the actions prior to the reinforcement were most responsible for it, and to alter its actions to aim towards more rewards in the future. So if he got the reward, then it's mean that was the right action. So then he will alter it, then he will learn from that one. So reinforcement machine learning is a behavioral machine learning model that is similar to supervised learning. However, the algorithm isn't trained using the sample data. This model learns as it goes by using trial and error. A sequence of successful outcomes will be reinforced to develop the best recommendation or policy for a given problem. So the training and testing phases are also intermixed in reinforcement learning. where you collect the information, the learner actively interacts with the environment, and in some cases it affects the environment, and they receive an immediate reward for each action. And then based on that one object, learn based on reward, punishment, and then made the decisions on that one. That's how it's called the reinforcement learning. And according to Wikipedia, it describes as a class of problems where an agent operates in an environment and must learn to operate using feedback. And according to the book in Reinforcement Learning and Introduction, second edition, reinforcement learning is learning what to do, how to map situations to actions so as to maximize a numerical reward signal. The learner is not told which actions to take, but instead must discover which actions yield the most reward by trying them. That's how, according to this, to the book of the Reinforcement Learning and Introduction, second edition. Now let's move to the third hour type, where we spoke on the semi-supervised learning. Now in the semi-supervised learning, it's basically the learner receives a training sample consisting of both labeled and unlabeled data. So supervised and unsupervised, and makes predictions for all unseen points. So semi-supervised learning is common in settings where unlabeled data is easily accessible, but labels are expensive to obtain. So various types of problems arising on application, including classification, regression, and ranking tasks, can be framed as instances of semi-supervised learning. So it falls somewhere between supervised and unsupervised learning, because they use both labeled and unlabeled data for training, typically small amount of labeled data and large amount of unlabeled data. The systems that use this method are able to considerably improve learning accuracy. Usually semi-supervised learning is chosen when the acquired labeled data requires skilled and relevant resources in order to train it or learn from it. That's how it is called as semi-supervised learning. So the training data contain few labeled and all that one. Now, according to Artificial Intelligence, a Modern Approach book, in semi-supervised learning, we are given a few labeled examples and must make what we can of a large collection of unlabeled examples. Even the labels themselves may not be the oracular truth that we hope for. And in the importance of huge sets of labeled data for training machine learning systems, may diminish over time due to the rise of semi-supervised learning. We can't talk about, because it takes some of that on that one, and then it built on top of it. So that's how we discussed common for four types of machine learning types, or the types of learning in machine learning, or methods we call it. There are some other methods, but commonly these are four methods are being used. Now, from a basic concepts point of on the machine learning, that's our last topic of today. And then I think in the next session, we will go in more detail how machine learning works. And then we will introduce some of the Python code, some of the data, or some of the programs or algorithms which are built to predict it. And even I'm doing it as part of my university this week. So I will be building some of the Python code to model train those as per the assignments. Now, from a basic machine learning concepts point of view, that's how, according to I think Dr. Pedro Domingo, University of Washington, and there are the way he took it, the approach that there are many different types of machine learning algorithms with hundreds published each day, and it's typically are grouped by either learning style, which is method, which is supervised or unsupervised or semi-supervised, or a similarity in the form of function. For example, classification, regression, decision tree, clustering, deep learning. So either based on the learning method or style, or based on similarity in the form or function. All the combination of the machine learning algorithms consists representation, a set of classifiers or the language that a computer understands, irrespective of style or irrespective of based on a function, or evaluation, objective, scoring function, and optimization. Search method, often the highest scoring classifier, For example, there are both off-the-shelf or custom optimization methods used. Now, how he defined, Dr. Pedro, that the three components of learning algorithms are, which is representation, evaluation, optimization. And that's the fundamental goal of machine learning algorithms, to generalize beyond the training samples. And representation, the way he wrote it, instances may be k nearest neighbor, support vector machines, hyperplanes, naive Bayes, logistic regression, decision trees, sets of rules, neural networks, graphical models. That's a representation. And then evaluation was accuracy, error rate, precision and recall, likelihood, cost, utility, margin. And in the optimization area, with the greedy search, beam search, or branch and bound, continuous optimization, unconstrained, gradient descent. We read it in, so we did it, the gradient descent in, I think, in session number 78 or 79. So you can go into the otechtalks.tv and you can find it under the podcast, under the machine learning and AI algorithms, the topics. We spoke on the, then it could be constrained, unconstrained, linear programming and quadratic programming. So how it has these three types of combination: representation, evaluation, optimization. That's all about the fundamentals of we can say about the machine learning. And these are all area was to just share with you how to learn and improve and start learning the basics of machine learning. And to summarize our talk of today, I think machine learning systems are used all around as of today, if you see it, and they keep improving it. And even if you are a guy who work on applications or ERP, even machine learning is being introduced into all the ERPs, and that's why a lot of vendors started calling about intelligent ERPs, where they put a lot of recommendations, a lot of based on the data, because ERPs are having the data. And even all these Google search engines, Siri, Alexa, and all those are based on using the machine learning, or digital assistants, or using the machine learning algorithms. Now, there are a number of, I think, last some bonus or talk about that, where to learn about it. If you are a guy or a girl or whatever whoever you are, so if you love to learn from the books, then I would suggest you that to start from a modern approach, artificial intelligence, a modern approach, or another book is Foundation of Machine Learning. If you can start from here, and both of these books are mentioned in the show notes. And if you wanted to learn from the courses, and I think the best course which is available from the Stanford University and the Coursera, which is from Andrew, AI expert from the Google, and these courses are the best courses to start one. And then there are some other courses which they started as part of Coursera, deep learning specialization course, or practical deep learning for coders. And then there's another course which is available from edX and Columbia University, Introduction to Machine Learning. That's I have also done that one. So you can start that one and there are some other resources available. So I did it a year back about Columbia University Machine Learning, and then this Coursera. But and then now from last 6 months and so, I'm into formal MSc in AI. That's why sometime you go in educational way. That way you will start learning from the very basics, and that's why I think nowadays I'm more into reading the books as an additional reading and start from there. So thank you so much for joining, and there are a number of other resources available, and I'll put it in the show notes, where you can start learning the history of the artificial intelligence and then the machine learning basics. Thank you so much, and before we will say goodbye, I would like to thank you, all of you, for sharing your feedback, sharing your comments on the social media, on the Twitter, and please like this session on on the iTunes. And nowadays, we're working on three primary areas. One is machine learning, artificial intelligence, data science, which is as part of my MSc course. And then the second area where is Oracle technologies, where I'm working my day-to-day job. So whatever I'm improving, learning, I'm sharing with you folks, and number of videos and lot of things we have done in OCI, because where we are seeing it, that's the future is on the cloud, where all the workload from on-premise workload need to move to or migrate to the cloud. So in those areas, if you're interested on that one, please visit otechtalks.tv and you will find it under the Oracle. Whatever daily learning, even if you want to learn from very basics, that how to provision or to move the workload on Oracle cloud infrastructure. And the third area is digital transformation, is a journal as a journal, and I'm just parking some more sessions on the digital transformation because those are also important. But right now, due to time constraint, these two areas are important at the moment. And that's how, frankly, if you ask me, I know from last 2-3 years when I did the courses about machine learning and all that, but when I went into theoretically, when I went into books and read the books, and then you link the things that, okay, what are the formal definitions? Otherwise, you just have general idea about different technologies, and that's why what I am doing is all about to learn, to focus, to improve myself. For example, last week we did this Sudoku puzzle problem as a part of machine learning or AI, foundation of AI. And then we did the basics of history of artificial intelligence. And then we did, all these, this is all gradient descent for machine learning, So all this is about to learn and improve and share with each other. Thank you so much. Have a wonderful life, blessed life ahead. Bye-bye.
Thanks for listening to the OTech Talks podcast, and be part of Tech Talks at otechtalks.tv. It's a turf to share ideas, insights, and innovations.